as till secondary level, we do only study about the real numbers, like all the numbers which we can represent on the number scale, all such numbers are known as what? Real numbers. But whenever maybe in secondary level you have find out the value of the root and you have find somewhere as -1 value, then you must be explained by your teacher that not to solve this number as this is an imaginary number. So how we are going to deal with such numbers? So we can deal with such kind of numbers with the help of the complex number. So as the name is suggesting, what is a complex? Complex means something which is a combination, is a little bit not as simple. It is having one or two more components together. We can say na, when things are complicated, then what do we say? We do say some things are mixed up with the some another things, right? I hope I'm making sense to you, Neha. Okay, so z is equals to a plus iota b. This z is representing the complex number, and this is the form of the complex number, as if we represent rational number by the form of p by q. So this is the format to represent a rational number where q cannot be 0. So in the same way, the way to represent the complex number, or what will be the way by which we will be saying that it is a complex number, so it will be a plus iota b, where a will be the real part and iota is representing the imaginary part, that is under root -1, and b will be its coefficient. So this will be the representation of the complex number, that is a plus iota b, where a is real part and iota b is the imaginary part. I hope till here you don't have any problem, both of you. Okay. Okay, now proceeding further, we have to remember only two values. I square is equals to iota square is equals to -1 and iota power 4 is equals to 1. You have to always keep in the mind these two values. If you will be clear, then you can find a 1 marks question from this topic. So please note it down, these all things, then I will take a question which you can find in your examination. I hope you both have noted this. Now, if we have to find the value, find the value of 1 plus iota raised to power 30, iota raised to power 20, plus iota raised to power 10. So firstly, I will arrange them into the ascending order of the I. It doesn't matter, you can solve it in that also, but I will do it in this way. So now how I have to find out the value for such kind of question? Then here I know two values, that iota square is equals to -1 and iota raised to power 4 is equals to 1. Okay, then I have to convert all these values either into the form of I raised to power 2 or I raised to power 4. Okay, so let's just start. If I do it iota power 2 raised to power 5, is it okay? Now I can do it iota power 4, iota power 5. Here I can do it as iota power 30. So we can break it in two ways. Either I will break it as iota power 2, then I will be left with iota power 28. Then I can solve it. Right now I have not substituted the values, I'm just and this will be iota raised to power 4 and this is 7. I hope this format is clear to everybody. Now I will substitute the values as I know. This will -1, this will give me +1, this will give me as -1. So when you will be solving, then you will be observing that answer is equals to what? 0. So the value to the given expression will be 0. Is it clear to both of you? You can see such kind of question in 1 marks in the paper. If anything is not clear, if any point is not clear to you, then please just ask me again. Neha and Viren, I hope it is clear to both of you. Okay. What about you, Mr. Singh? Is it clear to you? If it is clear, then I am writing a question, solve it at your own. In case you find any difficulty, then do ask me. Okay. 8 iota power 3 plus 6 iota power 16 minus 12 iota power 11. You have to solve this value and represent this value in the form of a plus iota b. Okay. Try it by yourself. In case you don't get it, just ask me in tomorrow's class. Okay. So now proceeding to the further topic of in the chapter, that is the conjugate of a complex number. So conjugate is nothing. You have to just change the sign of the imaginary part. This is real part and this is imaginary part. So in order to write the conjugate of a given complex number, you have to just change the sign of the imaginary part of the given complex number. Is it clear? As if my z is equals to a plus iota b, then its conjugate will be represented by z bar. It will be a minus iota b. If my z is equals to a minus iota b, then my conjugate will be a plus iota b. I hope it is clear to both of you. Please note it down if it is clear to you. Now next thing comes into the topic to find out the modulus. How do we find out the modulus? Modulus is equals to z bar. It is a square plus b square. That is the coefficient of real part and the coefficient of the imaginary part. You have to square them and just take their square root. Then you will get the modulus of the given complex number. Why we are finding the modulus, as we will be requiring it in the various other questions. मतलब तुमसे कुछ पूछना, कुछ बोलना, कुछ टोकना मना है क्या? नहीं, या कुछ भी बोलते तो तुम रहने दो, अभी मत टोको, मेरा मूड खराब है, ये क्या बात हुआ? Viren, kindly mute yourself. तुम इतना सा भी बात टॉलरेट नहीं कर सकते हो कि मम्मी हमसे पूछे या मम्मी हमको टोके? Viren, kindly mute. वो क्वेश्चन नहीं है पता किसी का भी. Viren, kindly mute yourself. I hope I'm audible. Kindly mute yourself. Neha, I hope I'm audible. Okay. So till modulus, I think it is clear to you. Okay. So now moving further, as we will, I will be take question on each and every topic. Firstly, I'm discussing the theory portion. What is the content in the chapter? Then we will be taking the questions. Okay. Because here we will don't get a a direct question to write the conjugate, to write the modulus. We will be using all these operations in a detailed question. So I will take a question in which all these operations we will be using. Okay. Okay, the next thing comes into the topic, that is the addition or the operations on the complex numbers. Operations on complex number. So as in the mathematics, we do have 4 basic operations, that is addition, multiplication, subtraction, and the division. So that we will be seeing in this here. So first operation is about addition. So how I am going to do the addition? Only you have to keep in mind the real part will be added or subtracted from the real part only, and the imaginary part we will be solving with the imaginary part. So I will take a question to this. Simplify 3 plus 2 iota plus 4 minus 3 iota. So how we are going to solve this? 3 plus 4 will give me as 7. 2 minus 3i will give me as minus I. So this will be the answer to the question. I hope it is clear to everybody. Neha, is it clear? Did not. As if we will open this bracket, then what we will get? 3 plus 2i. Here also I have opened this bracket, then I will get 4 minus 3i. As I told you, in order to add or subtract, we have to perform the operations on the same kind of numbers. That is, real number will be added or subtracted from the real part, and the imaginary part will be subtracted or added from the uh, imaginary part only. So as you can see, this is real part, this is real part. These both values are in plus. So 3 plus 4 I got as 7. Now this is 2i and this is minus 3i. So we already know about the concepts of the integer. Plus minus will give me as what? Minus. So 2 minus 3 iota has given me minus iota. Is it clear to you, Neha, now? Okay. Take one more question of the same type. If I am having a number as 2 plus 5 iota, this is a complex number. Another complex number is 3 minus 7 iota. And lastly, I do have 1 minus iota. So solve or add all the 3 complex numbers. As you can say, this is Z1, this is Z2, and this is Z3. Solve it and tell me the answer. What are you getting? If any of you have solved, then just tell me. Neha, what answer are you getting? Correct. This is minus 3 iota. As you can see, plus 2, this one plus 3 and minus 3 will give you a 0, and on solving the imaginary part, we will be having only imaginary part. Is it clear? In the way you can do the addition of any 2, 3, 4, 5, 6, 7, whatever the number of complex number will be given in the question. Okay. Now let's take subtraction question. If I do have as, if I take Z1 as 3 minus 4 iota, and I do have Z2 is equals to minus 3 plus 7 iota, I have to find Z1 minus Z2. So can you just solve? Then you will have to do in the way 3 minus 4 iota minus 3 plus 7 iota. Now here you will be getting as 3 plus 3 minus 3 and minus 7 iota. Then you must be getting 6 minus 11 iota. Is it clear to you, Neha? We have to multiply this minus sign inside. So this minus minus will become as plus. This minus has multiplied by plus, it has become minus. Then in the way you will get the, only in addition you don't have to change the sign, but while performing the subtraction, what you have to do, you have to change the sign of the complex number which is written in the back side or behind. Is it clear? Okay, so now take one more question. If I do have Z1 is equals to 5 plus 4 iota, and if I do take Z2 is equals to minus 6 minus 8 iota. Solve the value and tell. You have to find Z1 minus Z2. Please solve this question and tell me. Neha, in case you are having any problem, then you can ask me again. No, you are finding minus, Neha. Don't get confused. As I said, when we are finding what subtraction, then we have to multiply this given value with minus sign. Na? So what will be the answer? I am writing its solution over here, okay? Then this will be Z1 minus Z2. So 4 plus 4 iota minus 6 minus 8 iota. This minus will be multiplied inside. So 5 minus 4 iota, this is become minus 6, and this minus and minus will become plus. This will be plus iota. So this will be operated all together. So this will give me as minus 1, and this will give me as 12 iota. Is it clear, Neha? While doing the addition, you don't have to change any sign, but while doing the subtraction, you have to change the sign of the second complex number. Is it okay, or should I take one more question? Kindly do response me. It's fine. Okay. I hope, Mr. Singh, you are also getting. Now, after the addition, what will be the in the chapter? Uh, that will be the complex form. Complex form. Sorry, complex, not polar form of the complex number. We will say it in this. This will be polar form of complex number. So what is a polar form? As we are representing z is equals to a plus iota b, that means we are going to represent this particular values in the xy plane. Here x will be representing the real values and y will be representing the imaginary values, or you can say it is the Cartesian form of the complex number. So if I have to write a polar form is being telling us about the relationship with the angle and with the components. As maybe in physics you have studied about the vectors resolutions, then you have seen that if and we do see an angle, then we do get the two components with respect to x-axis and with respect to y-axis. Is it clear? Cos theta and sin theta. If you have not studied, then you will study in further, and also in the mathematics you will see in vectors chapter. So there I will discuss it in more detail. So the polar form of this same given complex number will be as that it will be can be written as r cos theta plus iota sin theta. So now in by studying this method, we will be able to convert a Cartesian Cartesian form of the complex number into the polar form and polar form into the Cartesian form. So in order to convert, I have to only find out what value of r and value of theta. Okay, so value for the r will be as under root a square plus b square. As we know, what is a is the real part of the complex number and b is the imaginary part of the complex number, and theta will be what? B upon a. You will say tan inverse b upon a. So on substituting the values, you can convert any given Cartesian form into the polar form. I hope it is clear to everybody. Okay. So next thing comes into the series of the complex number, that is the multiplication of the complex number. Multiplication of the complex number, left to note. Okay, I'm just going back to the page. Just note it down and tell me. Please do write tan inverse b upon a. Okay. So multiplication of the complex number is nothing. It's if you are clear with the binomial multiplication of the algebraic expressions, then you can do it in the same way. So if I directly take a question, let's evaluate 1 plus 2 iota is equals to 1 minus 3 iota. So if I have to find out the product of these two given complex number, then how I shall be? 1 multiplied by 1 will give me as 1. 1 multiplied by minus 3i will give me as minus 3i. Plus 2i multiplied by 1 will give me as plus 2i. Plus multiply by minus, I will get as minus 2 multiplied by 2, I get as 6. And iota multiplied by iota, I got as iota power 2. And I know iota power 2 is equals to minus 1. So I will be substituting this minus 1 over here. Then I will be getting plus 6. So now on solving, on collecting the real part all together and imaginary part all together, I will be getting as 7 minus iota. Is it clear to both of you? Okay. If it is clear, then solve this question. One plus iota, 4 minus 3 iota. Solve this. Tell me what value will you get? Let's see. I think you are getting a same. Then we will be getting as 4 minus plus iota. Neha? Is it clear to you? I hope concept is clear to you. Okay. Okay, so now moving further, this was about the multiplication in the similar way. If I will write one more bracket, then firstly multiply that, whatever value you will get, then multiply with the last complex number, then you will get the answer of the product of the three complex number in the way. Okay. So next topic which comes here, that is the division of the complex number. Division of the complex number. So what is division of the complex number? Let's see. I will directly take a question to this. If I have to divide 3 plus iota divided by 4 minus 2 iota. So this question will be in the form 3 plus iota divided by 4 minus iota. Till here, I don't think that any of you will be having any problem. I have just represented the given information in the form of the division. Now, from the here, I will be starting the solution. So whatever will be the denominator part, I will be multiplying it and dividing it by its conjugate. So here the conjugate will be of 4 minus 2 iota will be 4 plus 2 iota. 4 plus 2 iota. You can write multiply and divide by the conjugate of denominator, by the I hope it is clear. If it is clear, then it will be in the form 3 plus iota. Here I will be getting 4 plus 2 iota, and here I will be getting is 4 square minus 2 iota square. So this will give me as 12 plus 6 iota plus 4 iota, and this will give me as minus 2. I have directly substituted the value of I power 2. Then in the denominator part, I will be getting a 16, 4. Then I will be getting plus 4. On solving over here, I hope till here you are not having any problem. Divided by 20. So my A will be 1 upon 2 and my B will be 1 upon 2. Is it clear? Kindly do respond me if anything is not clear to you. If it is clear, should I proceed to the next question? If it is clear, then I am moving to the next topic, and this is the last topic of the chapter, that is to find out the square root of the given complex number. So how we are going to find, two more properties has been left in between. One is the additive inverse and one is multiplicative inverse. So firstly see that, and then we will be doing the square root. So additive inverse will be nothing. We have to just multiply it with the minus sign. So if I take number z as a plus iota b, and I have to write its additive inverse, then what I will be writing? I will be writing is minus a minus bi. Okay, I have to multiply whatever will be my complex number with the minus sign. Then I will be getting what? I will be getting my additive inverse. Okay, in the case of the multiplicative inverse, I have to just do its reciprocal. So if again I have as a plus iota b, then its multiplicative inverse will be 1 plus a plus iota b. So in order to solve this, again I will have to multiply it by its conjugate, and after solving that I will be getting the multiplicative inverse. I hope it is clear. In case you are facing any problem, any difficulty which is not clear to you, then you can ask me again. Here after this we have to multiply it by conjugate in the denominator and in the numerator part. Then what shall be getting? We shall be getting as a minus iota b upon a minus iota b. So moreover we can say that we can also write it in the simplified way, that the multiplicative inverse of any complex number can be as conjugate upon modulus square. Is it clear? If it is not clear, then please do ask me.